Okay, in this tutorial, I'm going to tell you how a headland and bay are formed, and I'm going to use diagrams to explain this process. I'm going to be drawing two diagrams, so you will need a piece of paper and a pencil, and you should make sure you draw all of the material to draw my diagrams, as well as adding all the key information annotations to the diagrams so they make sense. So, like with all things, first thing you're going to want to do is give your diagrams a heading. So we are explaining the formation of a headland and bay. So there's your first thing that you're going to want to write down at the top of your bit of paper. Now, because there's two diagrams, you can do these one under the other, or you could actually do them next to each other. Okay, so our first diagram, I'm going to draw a piece of coastline, okay, on my diagram. So here's my coastline. It doesn't have to be extremely even. As a matter of fact, let's just make this a bit straighter than that. That was a little bit unstraight. So here we have a piece of coastline, okay? And I'm going to divide my coastline into, we've got to imagine this is an aerial view, by the way, guys. So we're like a bird flying over the landscape. Now, if you're a bird flying over the landscape and you're looking down, you wouldn't see red indicating a rock or anything like that. But as long as you've got two colors or two different shadings when you draw your diagram like this, you'll be able to illustrate the two types of rocks. So my red rock, which I'm indicating here, is going to be my hard resistant rock. So I'm now going to add a little label that says that, okay? So I'm going to call this a hard resistant rock like. Now, it doesn't actually matter what is a hard resistant rock or a harder resistant rock, as long as it's harder than the rock that you have sandwiched in between, which I'm indicating here. Okay, so typically in the south coast, your harder rock, believe it or not, is actually your chalk, which is in itself actually quite a soft rock. But compared to the one that I'm going to put sandwiched between these two, it's actually harder. So let's just put a little arrow to indicate that. And then in between, we're going to have our softer, less resistant rock. Okay, so our softer, less resistant rock. Like, now, probably one of the weakest rocks I can think of is clay. So weak you can actually mold it in your hands in art, for example. And if you've got another color, we could just quickly just shade this in to show it's a different type of rock. Okay, so what else do we need to add to our diagram? Well, we've got the sea out here. So I just need to indicate that that's what that is in my diagram, because we're going to have waves. So let's just add a little label so I know what this is. Call it the sea. We can now tell we're on the coast. And my final part is actually that I want my coast to get attacked. So I'm going to add a series of arrows, because the coast is getting attacked by a range of processes. And these are where I'm going to be picking up lots of extra marks. So the coastline is eroded through a range of different processes. Like, okay, so we've got abrasion, and that is where waves throw rocks against the coast and cause it to wear away. Okay, and we're also going to have, let's go with the second one, hydraulic action. Where waves get into cracks in the cliff. Compress the air in the cracks and cause the cliff to break up. Okay, so there's two processes we've added to the diagram now. There is a third one. the coast is also going to get attacked, and I'm just going to go through it now. You wouldn't probably in a typical exam be required to do all three. As a matter of fact, just doing two would be fantastic. But I'll give you the third one, solution. So this is where the slightly acidic seawater dissolves certain rocks. Like chalk, as they are alkaline. So chalk is an example of a rock that's created from dead sea creatures. It's effectively the bones of dead sea creatures from millions of years ago. And water is naturally acidic. And if you know anything about the properties of acids and alkalines, acids actually dissolve alkalines. So this coastline is actually dissolving ever so slowly. Okay, so there we have diagram number one. We've got the key features are our coast is getting attacked by the sea. We've got three processes of erosion that are involved in the attacking of a coast, but we also know we've got two different types of rock. We've named them, and we've identified that one is slightly more resistant or harder than the other. So let's just go down and draw a second diagram. Okay, so this time, let's pick black. We're going to have to come in a little bit where our green rock is, our less resistant rock, because it is getting eroded faster. So let's just show our harder rock. Now, we don't need to say that this is harder rock again, because we've already actually got that on our earlier diagram. As long as the shading we use is the same as it was before, the person could flick between the two diagrams and get the point that you're trying to make. So we've got our harder and our softer rock. What's the key to getting a mark here? Well, we can actually get a couple of marks. I'll show you how to get the most obvious one. The key point for the whole feature is to say that the softer, less resistant rock is eroded by the sea at and this is key, so I'm going to put it in capitals, a faster rate than the harder rock. This results in a bay forming between two bands of harder rock which create headlands. Okay, I'm just going to put bay in capitals. Now, there's one final little extra mark you can pick up if you want to. It's just a way of squeezing another mark out of these questions. In the bay, because it's a dent in the coastline, sand often builds up. So this is where you actually find most beaches, in the middle of bay. So I'm going to pop a little beach in here, give it a yellow color. There we go. Give it some sand. And I'm going to add a little label to say beach builds up in bay as sand is trapped here as it moves along the coast due to, now I'm going to mention a word called longshore drift. This is brand new to you. This is actually a word we're going to come back to in lessons in a couple of lessons time, when you're going to learn about the fact that the sand moves around our coastline all the time, being pushed by waves that come at an angle. Now, you don't need any of that at the moment, but an examiner seeing you add a beach to the back of your bay and then explaining that longshore drift is what causes this would give you credit for that. So there we have our two diagrams. Diagram number one, we can see a fully labeled and annotated diagram showing what our coast looks like at the start. And we've got to imagine we're a bird flying over this looking down. We wouldn't be able to see the hard and soft rock, but if we could peel back the grass that's probably growing on these rocks, we would actually see that one of these was harder than the other. And then if we flew back 1,000 years later, we would see that the softer one was more eroded and that there was now a beach there. Okay, what you want to do is complete the diagrams, take a photograph, and make sure you place it into your Google Doc.